All right. Hello, everyone. So today we are going to talk about solving exponential equations. Okay. So I just really quickly want to go over something, and that's going to be how we change bases. So taking a look at our exponents, usually what we saw was something like this, where our base is going to be x, and our exponent is going to be whatever number is at the top there. So, what we're going to look at more today are bases that are not x. So bases like 2 or 3 or something like that. So with these, we still want to keep in mind that this is the same thing as saying 2 times 2 times 2. This is the same thing as saying 3 times 3 times, oops, that doesn't look like times 3 times 3. So we have 4 3s, we got 3 2s. Whatever your exponent is how many of that base you are going to multiply by itself. Alrighty, so sometimes with these, we are going to start out with bases that are not in the form that we want them to be. Let's say we have 125. So I want that to have the base of 5, but I need to figure out what my exponent is going to be. So the way we can do that is by saying 5 times 5. Okay, well, that's 25. And let's multiply that by 5 again. That'll be 125. That's what we're looking for. So it took us 1, 2, 3 5s to accomplish that. So that was 5 times itself 3 times. So I'm going to have a 3 as my exponent here. So we're going to come across quite a few of these. So let's try another. Let's do, let's say 9. Okay, I need this to have a base of 3. So I need to figure out how many 3s it's going to take me to get to 9. So let's do 3 times 3. Well, we're already there. That's already 9. So it took me 1, 2 3s to get there. So I have 3 to the second power. Okay. So that's the gist here, is that we're going to have to change numbers to be a certain base. So we need to figure out how many of that base go into that. Okay? All right. Big thing that I wanted to point out here is that we are not multiplying 5 times 3 to get 125. We are multiplying 5 3 separate times. We're doing 5 times 5 times 5 to get to 125. Okay? Alrighty. So let's get into these notes that we took. I'm looking at level 1. So use the property that if b to the x equals b to the y, then x will equal y to solve the equation. So looking at our example right here, we have b and b. Those are the same base. That is huge here. We have to have the same base for this to work. Okay, so we basically are going to find the base to be the same, change it however we need to make them the same, and then take our exponents right here and set them equal to each other. Okay, so let's do that here. Our first equation is going to be 5 to the x plus 3 equals 25. All right, cool. So this is telling me my base is going to be 5. I know 5 can go into 25. So what I need to do is change this 25 to have a base of 5. I just don't know what my exponent will be for it. So we're going to need to find that out. So let's do that. I got 5 times 5. I know that's going to be 25, so we're already there. This is going to be the same thing as 5 to the second power because it took me 2 5s to get there. Okay, so I'm going to rewrite what I have. This is 5 to the x plus 3 equals, now instead of 25, I'm going to put in 5 to the second power. I need these two to have the same base. So I'm going to put in 5 to the second power instead of 25. They are equal to each other. They are the same. It's just a different way of saying 25. So this is the point where I want to get to. You absolutely have to have the same base. They have to be the same for this to work. Okay, so Let's use our property here. This says that if we have the same base, our exponents will be able to equal each other. So what we're going to do is drop these bases. We do not need them anymore. They are no longer required. We're not canceling them out. We just don't need them. We're just going to drop them. And what we're going to do is rewrite everything that we have left. So I got an x plus 3, an equal sign, and a 2. So I'm going to write those in order. We got x plus 3 equals and a 2. Okay, now from here, all we got to do is solve. Just like we usually do, we've done this a bunch of times. We want to get x by itself. So my 3 is in the way here. It's a plus 3, so I want to do the opposite and subtract 3 from both sides. When that happens, these go away. They get canceled out. So we have x equals 2 minus 3. That's going to be a negative 1. And that would be my answer, is x equals negative 1. So the main thing here is you need to change your bases so that they match each other. And then once you're there, you got to cancel them out. And then start solving like we usually do. Okay, so let's go to the inside of these notes. I'm going to go over here to the very top. Directions say solve each of the following equations using the property that if b to the x is equal to b to the y, then x is equal to y. So that's exactly what we just did. We're going to do this again. So let's take a look at number 1. All right, we got 3 to the x, and then 81. Okay, looking at this, I see that my base is going to be 3. I know 3 will go into 81. So this is going to be my base. Therefore, I need to change 81 to have a base of 3. So the way I'm going to figure that out is by multiplying, we're going to multiply 3 by itself until we get to 81. So 3 times 3, that's going to be 9. Times 3 again, that's 27. Times 3 again, that is going to be 81. Cool. So that took 1, 2, 3, 4 3s. So that is going to be 3 to the 4th power. We have to change that first, or find that first before we do anything else. Okay. So we just found out 81 is equal to 3 to the 4th power. So we're going to take this 81 and swap it out for this 3 to the 4th. Okay, so rewriting, I have 3 to the x equals, instead of 81, I'm putting in 3 to the 4th power. These two things are still equal to each other. That's why I'm able to just swap them out. Okay, we got to the point where we have the same base. So once we get there, we can cancel these out. We do not need them anymore. They're being dropped. So once we drop those, I'm going to look at what I have left and just write that out in a line. Oops. So I got x, I have an equal sign, and I have a 4. Well, that's all I got to do for that one. That's it, because now we have x equals a number. That's all we needed. So there is that first one done. Not too bad. Okay, let's try another one. Let's do number 2. Okay, so we got 16 to the x minus 2 equals 4. Okay, I know 4 will go into 16, so this will be my base. 4 will be my base. So I'm going to need to change this 16 to have a base of 4. The way I do that is multiply 4 by itself until we get to 16. So I got 4 times 4, and we're already there. We already got 16. So it took us 2 4s to get there, so we got 4 to the 2nd power. Okay, I'm going to take this 4 squared, and I'm going to plug it in for my 16, because that's what I need. I need these to be the same base, so I'm just going to swap it out. So I got 4 squared. Ooh, but I still have all this stuff here. Well, I'm just going to take that. I'm going to put it behind my 2, but in parentheses. So I got parentheses x minus 2 here. Equals, all we have on the other side is 4. Okay, one small thing here is that this 4 does not have an exponent on it. So whenever you see that, as an invisible 1 as your exponent. So I'm just going to write that in there just so we could see it. All right. We've gotten to the point where we have the same base. Once you get there, you can drop these. Gone. So then I'm just going to rewrite everything that I have left in order. So I got 2 parentheses x minus 2 equals 1. Okay, now we're just going to solve from here. So I'm going to divide this into 2 pieces. I see that I have a set of parentheses here. So I'm going to distribute first. Remember, whenever you see parentheses, you got to distribute. All right, so we got 2 times x. That will be 2x. 2 times a minus 2 is going to be minus 4. And 1 is going to stay the same. Okay, cool. Still solving. I need to get x by itself. So I see that this minus 4 is in my way first. So minus 4, to get rid of that, we're going to add 4. So that is going to become a 0. I am left with 2x equals 1 plus 4. That is 5. Okay, one last step here. I have 2x, so I need to get rid of this 2. To do that, I'm going to divide by 2 so that that turns into a 1. I have x by itself, and I'm just going to leave this as a fraction exactly the way it is. We got 5 over 2. If we do that through, we have a decimal. I don't need you to find the decimal. We're just going to leave it as a fraction. And that would be our answer. So keeping in mind with these, fractions are fine. Fractions are totally okay. Don't worry if you get a fraction. It should be fine, just as long as you know your process is okay. All right, so that was 2 of the level 1 problems. I'm going to leave 3 and 4 to you for practice, okay? All right, so that's level 1. Let's talk about level 2. Now, level 2 is obviously going to be a little bit tougher, and that's fine, because we are mathematicians and we could totally handle it. So, only difference between level 1 and level 2 are going to be the bases. Now, in level 1, we already knew what one of our bases is going to be. We just needed to check which one went into the other. However, with level 2, you are going to need to change both of your bases. You do not know what your base is going to be for these. So you need to figure it out. You just kind of have to go with your gut and try and see if it works, okay? I know looking at these, I feel like we immediately want to say 4 goes into 8, but remember we're thinking about exponents. If we did 4 times 4, that's 16, which is way bigger than 8, so that does not work for us. You know, it does go into both of these, though, is 2. 2 will go into both of those numbers. So let's find out how many 2s it takes to go into 4. So I got 2 times 2. Well, we're already there. That's 4. So that's 2 squared. And then let's do 8. That's going to be 2 times 2, which we already said was 4, times 2 again. That's going to get us to 8. So that took 1, 2, 3 2s. So that's 2 to the 3rd power. Okay, cool. So we know 4 is going to be equal to 2 squared. So I'm going to take this 2 squared and plug it in for my 4. 8 is going to be 2 to the 3rd power. So I'm just going to plug in 2 to the 3rd power for this 8. You are just swapping them out. That's all you got to do. You need to have the same base so we can do this property. So all we're doing is just replacing this guy in here and this guy in here. All right, so let's do that and see what we get. So I got 2 squared. Just like in those other problems we saw before, I'm going to take this x minus 1, and I'm going to put it behind my 2 here. So I got x minus 1, all right, equals, now instead of a, we're going to put 2 to the 3rd power. Okay, now we're at a spot where we have the same base. So we can just cancel or drop these and rewrite everything we have left. I have this, this, and this. So I'm going to write those in order. I got 2 parentheses x minus 1 equals 3. All right, I kind of ran out of space, so let's move this over here so we can better see what I'm doing. All right, and we just need to solve. Boom. All right, so I see parentheses, so that's telling me I'm going to distribute. So I got 2 times x, that's 2x. 2 times a minus 1, that's going to be minus 2, equals 3. All right, this minus 2 is in my way first, so I'm going to add 2 to get rid of it. That means this is gone. So I'm left with 2x equals 3 plus 2, that is going to be 5. And then last step is going to be dividing by 2. So that turns into a 1, and we got x equals, like I said before, you don't need to find the decimal. We're just going to leave it as a fraction. So you get x equals 5 over 2. And that is our answer. So like I said, only difference between level 1 and level 2 is going to be the fact that we need to change both of the bases this time. These do not show you what your base should be. You have to figure it out. Okay, so with that said, let's check out the first problem. Okay, so we got 25 equals 125. Okay, like I said, you have to figure out what your base is. Now, looking at this, looking at these two numbers, my soul, my gut is telling me that my base is going to be 5. So let's try and see how many 5s it takes us to get to 25. So 5 times 5, 25, we're already there. Okay, that was 1, 2 5s, so I got 5 to the second power. Now I need to find 125. So 5 times 5 times 5 again. That will work for us. Cool. So that'll be 5 to the 1, 2, 3 third power. Cool. All right. So now the next step is going to be replacing what we need to. So 25 is the same thing as 5 to the second power, so I'm going to take that and plug it in here. 125 is the same thing as 5 to the third power, so I'm going to take this and plug it in for 125. Okay, so rewriting my problem. 25 was the same thing as 5 squared equals 125, that is 5 to the third power, and I still have this little x up here. So I'm going to take that and put it in here with parentheses. So we got x in parentheses right there. Okay, cool. That gets us to the same base, which is what we have to have before we can do anything else. So we could drop those bases and rewrite what we have left over. So I got 2 equals 3 parentheses x. Okay, solving from here. I see I have a set of parentheses, so I'm going to distribute this 3. So I'm going to get 2 equals 3x. And then I need to get rid of this 3, so I'm just going to divide by 3. So then I should have x equals 2 to the 2 over 3. Okay, cool. That is number 5. So let's try number 6. Okay, so both of the bases have to change. Looking at these two, I got a 9 and a 27. My soul is telling me that 3 will go into both of these numbers. So let's figure out how many 3s it takes us to get to 9 and how many 3s it takes us to get to 27. All right, 3 times 3, that's 9. We're already there. So that is going to be 3 to the second power because we took 2 3s to get there. All right, now let's find 27. 3 times 3 is 9, times 3 again. That'll get us there. Okay, so that took 1, 2, 3 3s. So I got 3 to the third power. All right, now to replace what we just figured out, I know 9 is going to be equal to 3 to the second power. So I'm going to take this and plug it in. I know 27 is equal to 3 to the third power. So I'm going to take this and plug it in. Okay, we said that was 3 to the second. I'm still going to take this whole thing and plug it in here with parentheses. So I got 3x minus 1. Cool. Equals 27 was equal to 3 to the third power, so I'm going to plug that in. 3 to the third. Okay. Both of our bases are the same now. So I'm going to drop these. I no longer need them. All right. I'm going to rewrite everything that I have left in order. I have 2 parentheses 3x minus 1 equals 3. Awesome. Okay, gonna start solving now. So I'm gonna separate this. I see that I have parentheses, so I'm going to distribute. Okay, 2 times 3x is going to be 6x. 2 times negative 1 is going to be negative 2 equals 3. Okay, we're solving. So I see I have to get x by itself. This minus 2 is in my way, so I'm going to get rid of that first. Plus 2. These cancel out. So I've got 6x equals 3 plus 2, that is 5. Okay, got to get rid of that 6 next. So I'm going to divide by 6 on both sides. Oops. These cancel out, so I have x equals 5 over 6. Okay, so I know I went through some of these pretty fast, but the only new thing we're seeing here is going to be this step right here where we have to change our bases. That is the only thing that is new to us. We've been solving since the beginning of the semester, so this part should not be new. This part should just be review, okay? This is what's new to us, is this base changing bit. Okay. All right, so I'm going to leave 7 and 8 for you to do, but that is going to be the notes that we took on solving exponential equations. All right, have a good day, everyone. Let me know if you have questions. Bye.